Okay, thank you for this afternoon. First of all, I'd like to probably acknowledge that this is a truly collaborative approach on this project. We have Pelican Waters represented this afternoon by Phil and Hamish. We have Sunshine Coast Council a part of it. We've had the University of Sunshine Coast, Spell Environmental, obviously Covies, and Hall Contracting. So using floating wetlands, you could actually replace the word floating wetlands with hydroponics. As most would know, hydroponics is the cultivation of plants into a water layer without soil. So that could be easily replaced by the word hydroponics, and that'll come up later on. So what we had with Pelican Waters, we had on Pelican Waters stage 3, is this pointer, where's there a pointer on this? No. Yes? Where is it? Oh, there. So Pelican Water Stage 3, this is what the original design was. We had some dry lots in here, a parkland area there, and some wet lots or waterfront lots here. The original approach worked in a traditional sense, but provided limited waterfront access and also required a considerable amount of drainage. And they had numerous detention basins in this park area here and bioretention basins. Pelican Waters asked us to do a substantial review on the layout to see if we come up with a more efficient design. So what we looked at there is how we could use some floating wetlands, which we'd already trialled elsewhere, both on the Sunshine Coast and further north at Gladstone. But what hadn't been trialled is for their use in saline waters. So we looked at using the floating wetland system to create a canal or extend the canal back into here. And what that gave is a greater waterfront development. We went from previously, I think there was something like 18 original waterfront lots here and here, to we end up with 30 waterfront lots here, total, and reduce the number of dry lots back, but all these dry lots then had water views. So, but what the big saving was a reduction of stormwater or stormwater pipes, which is assets that council had to manage that flowed through the centre of the area. So how does floating wetlands work, or how does this system work? Floating wetlands, it's a novel approach. It's a new approach that's being tested. We have the macrophytes that are planted in this buoyant layer up here, as we said, similar to hydroponics, and the root mass, that is what does the filtering down here and the water quality treatment. If you look at that root mass there compared to a traditional wetland system, the root mass has a massive area. When you look at all the root areas or the little root stems, the massive area on those for treatment. So this allows the roots to go into the water column and do the uptake directly into the root system, and then you have obviously the shoots coming out from the top. The other thing it does do is actually slows the water flow down and allows sediment to drop out directly below the root mass. So it reduces the energy of the stormwater as it flows through. So ultimately, this approach here, using floating wetlands, is ideal for end-of-line treatment or in the low coastal areas. So when you've got low coastal areas, you don't have the hydraulic grade line or the water to push through a traditional stormwater system. So as I said before, that area which had the original stormwater, the reduction in stormwater alone, in stormwater pipes, was approximately 650 metres of 1,200 diameter pipe, which is a considerable saving, both for the development but also council's asset management going forward. And the other advantage was the additional waterfront lots that we created in that area. Right, I've got a face here. Okay, the main benefit of this approach was, I'll just check my notes on this one, because there was the biggest benefit was at the saving. So we had the infrastructure that was saved, we had the waterfront amenity that was created, but what we did have was a 15 hectare upstream catchment that had no treatment at all occurring. So what we did, we directed that catchment into its own embayment or its own floating wetland system. So an area that previously flowed into Pumice Stone Passage with zero treatment at all now flows into one of the stormwater treatment embayments. And that was because of this hydraulic grade line, or where we couldn't achieve traditional water quality treatment into that area. So this is a current photo of the wetland system. And as you can see there, we have the growth in those plants. And even though this is a saline system, which people think that very little grows in a saline system, we have phenomenal growth that's occurring both above the water, but also the root mass below the water. And as you can see there, it provides an aesthetic solution, but what it does provide is an aquatic habitat directly below the floating wetlands. So with this, the project validation. This is where Jane will take over, but in order to validate this system, we worked with Sunshine Coast University and to develop a research project. This was to determine the plant species that would grow or develop into a saline waterway, determine how the root masses would disrupt the flow, in other words, drop out that sediment that the normal stormwater picks off of streets properties, determine the local based reductions that would occur in the stormwater treatment for pollutants that would flow off that area, and also determine the cost benefits of providing this system versus the traditional water quality treatment systems, as in biobasins, the street bios, and all those things were looked at as part of this trial. So what I'd like to do now is hand over to Jane Louise, who conducted the trial on behalf of the university.
Thanks, Kevin. Okay, hello again. So I'm going to focus on the water quality component of it. So I talked to you about how the university is evaluating how effective these floating wetlands are at removing the nutrients and the sediment from the embayment, from the stormwater, so that they don't get into the waterways. So the sampling began in February 2018, and it's ongoing as recent as this morning. What we were doing was we were looking at collecting samples from the embayment at the beginning and the end of each of these wetlands. So if you have a look at, you can see in the back of the picture a sandstone. That's generally in each wetland where the water's coming through. And then we measure it again, you can see a couple of white hoses coming out of the end of the wetlands. So we did this during rainfall events and then collated the water and had a look at that. So this just shows you the early stage of the wetland development. So the first 18 months of results, the data was really inconclusive, and that's very frustrating from a scientific perspective. One of the major challenges that we were having, if you have a look at those red circle bits on the data sheet and the inlet columns, the inlet concentration of the nutrients, the phosphorus and the nitrogen, was generally lower than the limit of detection. If it's not there, you can't evaluate how effectively it's being removed. So that was a real challenge. We weren't sure whether this was an artifact of the fact that the development as itself was in an early stage of development. So in those previous photos, you might have noticed that there weren't a lot of houses. It wasn't fully, there were still many vacant lots there, or whether it was an issue with the way we were sampling. So other challenges were it didn't rain. So it was particularly dry 2018 and 2019. When it did rain, you had things like a mollusk had taken up residence in your inlet hose, or as we had this morning, the team got to site to grab a sample and you found that some curious kids had pulled the outlet hose out. So you can't evaluate effectiveness if you don't have an outlet sample. We also had some staff changes at USC, and we ended up having a whole new research team. So when this research team looked at the data, they went, hey, that salinity data is a little bit curious. Is that a tidal influence, or is that some sort of stratification occurring in the embayment? So we sat down and talked with all the stakeholders, and a simulated rainfall event was proposed because we couldn't wait for it to rain heavy enough, and we couldn't control whether our rainfall was going to contain sufficient nutrients. So Pelican Waters and Halls Contracting were really amazing in this, and we were trying to work out, was it feasible and did we have salinity density gradients occurring? So we did some initial trials with flow. We did them at Wetland C because it was the smaller catchment and we had a better chance of being able to generate sufficient simulated rainfall event flow. So they went out and they looked at used a salinity probe, put some hydrant water down the drain, and we worked out that yes, stratification was occurring inside the inlet pipe. Then we went out again with them, and we used some extra water from a water truck, and we took salinity measurements at different heights in the embayment and at different stages across the length of the wetland. And we confirmed that, yep, it looked like we had this halocline where the fresh water was coming in and sitting above the top of the salt water, and we weren't getting a lot of mixing. So that was enough information for us to then proceed with our simulated event. So what we did was we did a full-scale event. We had lots of water, and I can't read the number from there. There you go, 53,000 litres of water over 26 minutes. And as we were running that water through, we were taking samples every 2 minutes to try and get what was occurring across the event. We took samples at a couple of different levels. So you'll see 1CA, 2CA, they're both water inlet positions. 4CA is where we added our slurry mix, so nitrogen, phosphorus and some sediment. Our first water quality measurement was taken at 5CA. So 5CA was a spot, it's in a stormwater pit where there wasn't any saline influence occurring in normal high tide events. And I'll point out that we did it at low tide to try and limit the effect of any tidal influence or of the salt waters in the canal water. So we measured at that 5CA, so trying to establish what the raw stormwater quality was. We measured again at the pipe where we'd got those original stratification measurements. We measured at the beginning and the end of the wetland as we had previously, and the extra 2 spots that we took water samples from was at the beginning of the wetland and at the end of the weir, but this time at fixed heights, because our initial investigations in that second proof of concept measurements was that we thought that the stratification was happening somewhere in the sort of top 30 to 40 centimetres of water. So we wanted to establish that. So a really hectic 26 minutes that involved lots of planning for 7 organisations. If you follow the flow of the pictures from left to right, you can get a bit of a visual of what happened. What did we find? So the great news was that the simulation experiment was a success. And the fact that we were able to replicate flow that was similar to natural rainfall events that were occurring in that catchment, and also that we were able to get our slurry mix had sufficient nutrient, phosphorus and sediment concentrations similar to what's projected in the literature. As a whole, the floating treatment wetland system met the nutrient and sediment requirements for load reduction that exist in South East Queensland planning policies. And that's a really good sign as well. We're mindful that it was a one-off experiment, so more research will be done there, but it's a really promising sign for us. We also were able to confirm that there was a density gradient happening there with salinity. So that had some implications for how we were going to monitor further on. And it also had implications for how floating treating wetland systems might be designed in the future and the embayment. Like all really good research, it raised several new questions. And one of those was, what's happening with that sediment and how does it move through the pipe and through the embayment? That's beyond the scope of this research, but it's something that we could look at in the future and which will certainly be an interesting study. So we modified our water sampling thing. We added additional spots at wetland C, but we also went back to wetland A and changed that one as well. What we found when we were looking at the results of our study from our in situ simulation experiment, when we went back and compared that data with the previous data, the early data, was we weren't quite sure what heights the original data was collecting samples at. So to maintain integrity of our data set, we kept sampling at the old system, but we also added at the beginning and end of each wetland a pickup point for samples 200 mils below the top of the water. As you can see, there's some samples taken. On your left is the darkest, so as it flows through the system from the pipe down to exiting the wetland, visually it looks good. And collaboration was the key to this project. So constantly working with the developers, with the engineers in the uni, and with Halls Contracting and everybody, and Spell Stormwater, and everybody working together to try and answer some questions, raise new questions, and resolve some issues there. Special thanks also to Sunshine Coast Council, who approved the original floating treatment wetland research, and also that approved us to conduct the in situ experiment, because it was a very hectic day. If you'd like to know more, Luke Verstraeten's got a poster just as you walk out the door, and he'll be talking about that in the next session. Thank you.
Thank you both. There's a question. There are a few questions here.
Come on, Jane, you've done the research.
We'll put them to Kevin. There's a question about, are you concerned about possible sea level rise with climate change? Do you think developers will accept some responsibility to people if properties are inundated? And I guess, you know, it specifically focused on the wetland, how is climate change going to affect it? I'm going to add another question, and that is, given climate change, are you convinced that the vegetation that you're using in these wetlands is adaptable to the future, the climate future we're going to have?
Yes. I don't know the answer to that. I think with the vegetation, adaptive management is similar to what Mark was talking about earlier, is going to be the key. Constantly watching the plants, and the beauty of floating wetlands is you can change those plants in and out. So you've got a lot of flexibility here. Things like Pumice Passage breaking through may also, Bribie Island, the breakthrough, if that continues to happen, that may also influence the water quality parameters of water that's coming in and out, because it is a tidal flow system. So I think that's too big a question to answer at the moment, but is something that is continuously monitored. Certainly during the life of the project, and plants is also a species for our discussion for another day, because it's a broader issue. We swapped some plants out in the beginning and put in other plants that were more appropriate and better able to cope with it. Remembering that this floating treatment wetlands system is brand new in a saline environment, so it really is a learning opportunity for us.
Yes, and as Jane said, we actually trialled, before we actually started the trial system itself, we tried different plants to see what would survive in the saline environment, and the ones that survived best, I think there was 3 types which we planted in those wetlands. On the climate change issue, as most would know here, when you're designing new estates, climate change must be taken into account. So with sea level rise or climate change, all new developments now must be lifted or, you know, seek or achieve the minimum flood level to allow for climate change. And with floating wetlands, because they do float on the water, if there is climate change or sea level rise, they will just rise up with that, with the sea level.
We might have time for just another quick question. Is a reduction in canal dredging predicted as a result of the floating wetland?
Sediment obviously is caused by 2 things. One is from runoff from the land or the developed area, and the other one is from the canal itself, movement of sands up and down the canal from tidal influences. With the embayment we have here, we have a end wall or a barrier at the end of the embayment, which will help gather any sediment that does occur. And all these 3 embayments on Pelican, they've been allowed that they can be cleaned out if there is sediment build-up from stormwater runoff off the land.
Thanks, everyone.